of astronomy and some important things that have changed. Telescopes are probably the most important instrument that astronomers use. And 100 years ago, they looked a little bit like this. I'll see if I can turn the lights down a little bit. So you can see these pictures a little bit better. Oh, that's very dark. I'll turn the lights up again. This is one of 100 years ago. This is the world's biggest telescope at Mount Wilson in the United States, and it's about a 2.5 metre wide mirror, so roughly about the size of the desk here. Well, today, telescopes look like this. This is the Hubble Space Telescope, and it's got a mirror that's about the same size as that 100-year-old telescope. The difference is, rather than putting telescopes on top of mountains, we can now put them in space. And I think that's an incredible scientific achievement and technology achievement to do that. 100 years ago, computers in astronomy looked like this. They were rooms of people. We didn't have computers like we have today. A computer was a person who was employed to do mathematics. And at the time, it was a lot of women were employed in this role. Whereas today, as young women, you've got great opportunities to study science and work in scientific careers. So that's a fantastic thing that's changed over the last 100 years of science. But our computers today look a little bit more like this. There's supercomputers that we use, great big banks of equipment, sitting in nicely air-conditioned rooms. A great place to go today because it's a bit warm is down to your local supercomputer centre and enjoy the air conditioning. 30 years ago, computer games looked like this. Does anyone know what game this is?
Space Invaders.
Call it out. Space Invaders. It's one of the classics. As a boy, I actually didn't spend my time. I was old enough to be playing Space Invaders, but I didn't. Very simple graphics. Very revolutionary change to the way that people got their entertainment. Well, today, as I'm sure you all know, computer games look a bit more like this. Really lifelike graphics in them, amazing gameplay that can go on in them. And a lot of that is thanks to what's called a graphics processing unit. It's a little tiny computer chip that sits inside your games machines, and it allows your computer to do these amazing amount of computation in order to produce those great looking graphics. And it's the GPU, the graphics processing unit, that I'm very excited about. And the reason is that we built our supercomputer at Swinburn University, where I work, using graphics processing units. And for me, they turn out to be about 100 times faster than a normal computer, but at a fraction of the cost. So I can now do some amazing computations and calculations in astronomy that I just couldn't have done ever before, thanks to this new technology. And it was people like you playing computer games and buying computer game hardware. Well, I'm sure your parents spent the money rather than you great young scientists. But the new developments allowed scientists to take advantage of this. And that's another thing that scientists are very good at, taking advantage of opportunities when you see them to do something clever. So this is the clever thing that I do with them and my students work on. This is what's called a magnification map. And it's a little bit crazy looking. It's a little bit like the patterns you see in the bottom of a bathtub when the ripples of the water focus the light down onto the base of the bathtub. And we don't use it to study bathtubs though. We use it to study supermassive black holes in very distant objects called quasars, half the way across the universe. And what we need to do is create lots and lots of those maps. And our GPU supercomputer has allowed us to create nearly 50,000 of these maps in about a year. That's more than anyone had ever done of this before. To give you a sense of how much data, how much information that these great GPU supercomputers give us now, we're talking about filling up thousands of DVDs just for this project. So that's amazing, the amount of data that we've got to look at. But something else I'm really interested in is new ways of looking at data. And here's what's called an optiportal. And this is a very large number of computer screens that are linked up together that allow us to look at incredibly large images. And this is a great way for us to learn more about the universe. So in your future, astronomers are going to use this thing here. Now, I'm hoping there's one person in the creative writing who I think wrote about the square kilometre array. Are you here today? Fantastic. So you can come up now and say, no, I won't do that. Because it's all about the square kilometre array, which is a very new radio telescope that's being built partly in Australia and partly in South Africa. And it's going to take about the next 5 or 10 years to build it. So by the time you guys are actually thinking about maybe going to university or you will be at university, the square kilometre array will be here in Australia and ready for you to go and start using it. And I think that's a very exciting thing. To do that, to build the square kilometre array, we need a really, really big computer. Bigger than the top 250 supercomputers in the world all combined together. And we'll need as much internet just to run this telescope as currently exists everywhere on Earth. So to do that, we need better computing technology and we need cheaper computing technology and better energy sources and better ways of transferring data and so many problems that need fantastic creative solutions, groups of people working together, and more of you guys playing computer games, because every time your parents buy a computer game or a new bit of hardware, we get a better GPU into the future. So hopefully I've convinced you and your parents that astronomers of the future are counting on you to play as many computer games as you can. You've got a reason to do it now, so that the astronomers of the future can use great instruments like the square kilometre array. Thank you.